Okay, good morning or good afternoon. Today we're going to learn about integration by substitution. So for some integrations involving a complicated expression, we can make a substitution to turn it into something simpler. So if we can't use the reverse chain rule on a question like this, so let's look at it. So remember, for the reverse chain rule, we were looking for a function and its derivative. That gives us a clue that we can reverse the chain rule. We don't have that option here, and you don't know how to integrate this as it stands. And if you try to expand that, it goes on forever. It's an infinite expansion, so that doesn't work. So what we're going to do is we're going to use a substitution, and usually they'll tell you what substitution to use. So here, the aim is to completely remove any reference to x and replace it with u. We'll have to work out x and delta x so that we can replace them. So we start off with an expression, an integration in x. We're going to end up with an integration that's got u's and it's got a du at the end. Okay, you cannot integrate a function in u with respect to x. So this has got to end up being some function of u du. And what we do is we're aiming to make it more simple than it is at the moment. So let's start off with this question here, okay, which is we are going to integrate with the suggested substitution of u equals 2x plus 5. Okay, so step 1, using substitution, work out x and dx or variant. So what we're going to do is we're going to take u equals 2x plus 5 and we're going to find du dx. So let's differentiate u with respect to x, which is 2. Now, what that means is, if you look at this now, du dx equals 2, we're now able to find out what dx can be replaced with. So, bring the dx up, you end up with du equals 2dx. So, a half du is equal to dx. So, looking at this, look, that I could now replace with that. Okay, let's look at what else we can replace. So 2x plus 5 can be replaced with u because u equals 2x plus 5. The only thing that I'm not able to replace yet is this x. But if I rearrange this, I can get x equals, so subtract the 5 and divide by the 2. So x equals u minus 5 over 2. Okay, so now we're in a position to substitute everything into the expression. So we're looking for the integral of x, which is u minus 5 over 2, multiplied by the square root of 2x plus 5, so u to the half. And then we've got to, this is the bit students always forget, we've got to replace the dx. So dx gets replaced with a half du. So times a half du. And now we need to tidy all that up. Okay, so let's do that now. So I've got a quarter, I'm going to take it on the outside. That's from this half here and this half here. Okay, so a quarter times the integral of u times u to the half is u to the 3 over 2 minus 5u to the half du. And what we've got now is something really nice and easy to integrate. So it's a quarter times u to the 5 over 2 over 5 over 2 minus 5u to the 3 over 2 over 3 over 2. Okay, and when we tidy that up, let's just go back. I'm trying to cheat a bit here. So when I tidy that up, I get a quarter times 2/5 u to the 5 over 2 minus 10/3 u to the 3 over 2. Okay, so finally I'm going to now, I'm not quite finished because my question was a question in x, so I need to go back and replace my u's with my x's again. Oh look, and I should have done that in this box here. Right answer in terms of x, so I'm now going down here. All right, so we've got a quarter times 2/5 u, which is 2x plus 5, to to the 5 over 2 minus 10/3 u to the 3 over 2. And then don't forget your plus c. I should probably expand that bracket out actually because it's a bit mucky, isn't it? So we've got 2/20, so a 10th, minus 10/12, 5/6. Okay. So that's your answer. Okay, so that's integration by substitution. So usually we're told which substitution to use. Okay, if we're not given it, there's no hard and fast rule, but it's often helpful to replace expressions inside roots, powers, or denominators. Okay, so here that would be a sensible substitution. In this question, power would be a sensible substitution. Although you can do that by inspection, by reversing the chain rule. Here, the denominator would be a useful substitution, and here the power would be a useful substitution. Okay, let's do another one. So we've got u equals sine x plus 1. Okay, you can see how that would be a useful substitution here. So we're going to start off, first of all, by taking u equals and differentiating it. Okay, so u equals sine x plus 1. So du dx equals cos x. So therefore du equals cos x dx. Now I'm going to leave that as cos x dx because if you look back up here, that means that that and that both get replaced with the du. So that really helps me. So now I've got that bit sorted, that's fine. I've got that bit and that bit sorted. The only thing I need now is a sine x. So I'm going to rearrange this to get sine x equals u minus 1. So now we're ready to substitute in. So we have the integral of the sine x, which is u minus 1. So that's this one, okay? And then we've got 1 plus sine x, which is u cubed. And as I said before, the cos x dx gets replaced with the du, okay? So that gives us the integral of u to the 4 minus u cubed du. So we're going to integrate that, so that's a fifth u to the 5 plus a quarter u to the 4, which is, I've just done these in the wrong place again, a fifth sine x plus 1 to the 5 plus a quarter sine x plus 1 to the 4 plus c. Okay, nice.